Hi all, in this video I'm going to continue a little further into what it means to be inverses and how we actually find inverses. So we've got this idea that two functions are inverses if when we compose them we get back x. So we know that f inverse of f of x should give us back x, and we know that f of f inverse of x should also give us back x. To get a little further into this idea, we basically want the inverse of f to undo every single operation that f performs on our variable. And to get the operations to really cancel each other out, which is what we're hoping, we need to make f inverse undo each thing and go in the opposite order. So I want to just walk through this list right here and see if we can work our way up to it. And then we'll get at how we would do this algebraically so we don't have to make a whole list every time. So I'm describing what a function does here. I have function f. It takes an input. The first thing it will do will be to add 2 to that input. It will then cube whatever I've got, take the result of that, multiply it by 4, take the result of that, subtract 3, and that will be my output. So f inverse needs to do exactly the opposite. The thing we're plugging in will still be called the input, but it is important to notice that the thing we plug in to f inverse should match up with the thing we would get out from f. So I'll still call it input, but it does have a relationship with this output of f. Okay, so we need to go in backwards order. So we're going to go to the subtract 3 first. If we would like to undo subtracting 3 from our variable, we should start by adding 3. And it's really important that when we compose functions, which is what we're going to do, the plus 3 and the minus 3 are right next to each other in order of operations. Otherwise, they won't cancel. And that's why we have this reverse order thing happening. F. Okay, so f, second to the last thing it would do is multiply our variable by 4. So the second thing that f inverse should do is divide by 4. So inverse functions absolutely involve inverse operations, and we have to figure out not only the inverse operations, but also the correct order. Before that, f would have cubed whatever it had. So we want to cube root. And very first thing it did was add 2 to our variable. So we want to subtract 2. That's the very last thing f inverse will do. And then we will get an output. And once again, it's really good to recognize that that output should match up with what would have been an input for function f. So the input-output pairs for f should match up with an output-input pair for f inverse. Inputs and outputs get flip-flopped. Okay, so I'm making this claim. We don't just have to believe it, we can check it. So if we're working on, let me block this off, function f, and f takes our variable and adds 2, and then cubes whatever I've got, so parentheses are really important, we're cubing the whole thing, and then multiplies it by 4, and then subtracts 3, this should be an equation for f of x. I'm making the claim that f inverse should do exactly the opposite of every operation that f performs, and it should do it in the opposite order. Going on that, I've got the steps that f inverse should walk through. So we give it an x. The first thing it will do is add a 3. It will divide all of that by 4. It will then cube root everything I've got so far and subtract 2. So this should be the formula for f inverse. And we should be able to verify whether or not we were right in making this list for f inverse. What it means for functions to be inverses is that when you compose them, you get back just a plain old x. So we can use this to check. And we could check both ways. I think I'll just pick one for now so you can see me walk through the algebra of one of them. So here's our check. Let's try f of f inverse of x. And again, it should work both ways. I'm just going to walk through one right now, but it should work both directions. So f of f inverse of x will be f of the cube root of x plus 3 divided by 4 minus 2. Okay, so this first step can look really messy, but the simplification should be very nice after that. Every once in a while, they get a little messier. If rationals are involved, the algebra can be a little bit messy. But for most of these functions, if they're inverses, each operation that you see in one of the functions should get wiped out by an operation in the other function. So function f is going to take whatever I give it. It's going to add 2, cube it, multiply by 4, subtract 3. So if I take my input, it should do exactly that. It should add 2, it should cube the entire thing, should multiply the result of that by 4, and subtract 3. Okay, so this is a mess. And again, generally in that very first step when you compose the functions, it looks really messy, but nice things should happen. I do need to see enough work on this so that I know what order you think things canceled out in. That's important to me. So looking at this, the very first thing that's going to go is the negative 2 plus 2. So here, let me snag a color. This right here is the first thing I'm going to lose. That pen does not work. Okay. The parentheses in here around my input, I don't need. There's no multiplication attached to them. There's no operation, or I'm sorry, no exponent attached to them. I can just drop them out. I don't need them to separate off the addition. So the 2's drop out, and I'm left with the cube root of x plus 3 over 4 cubed minus 3. The next thing to go is going to be the cube root and the cube. Those happen in order, one right after the other, so they should just wipe each other out. Right now, the multiply and divide by 4 do not happen one right next to the other in order of operation, so they won't cancel out yet, and the same thing with the plus 3, minus 3. But right now, order would say I cube root and then I cube, and if you cube root and then cube, you're just going to get back where you started, which was at x plus 3 divided by 4. Okay, I'm getting close. Now the divide by 4, multiply by 4 happen right next to each other. So if I plugged in an x, I'd add 3, I'd divide by 4, I'd multiply by 4. Those two would wipe each other out. And finally, the plus 3 minus 3 end up right next to each other. And it looks like, am I getting off the bottom? Just barely. F of f inverse of x is just leaving me with x. This is exactly what I was hoping would happen. So this is a good sign. It looks like I do in fact have inverses. If you'd like just to practice the algebra, you can try checking f inverse of f of x. You should end up with a plain old x again. If you don't, you're making an algebra mistake somewhere along the way. But I want to continue because we haven't really gotten to the big point of all of this. So this is wonderful. We now know what f inverse should do, and we know how to check and make sure that f inverse actually does that. But we don't have a great method for how we actually find the equation for f inverse. We could do this every time, write down a list of what f does, and then write down a list of doing the opposite of each thing in the opposite order. But we actually know a really nice trick that involves reversing everything that happens to a variable in the opposite order. And that trick is just solving. If you are solving an equation for, say, x, and there's only one x on one side of the equation, that's exactly what you do. You take off everything attached to the x by using inverse operations and applying them in the opposite order. So the algebra trick, and it actually says this up at the note in the top, the algebra trick for doing this instead of having to write out lists is you swap your input and your output variables, so x and y in this case, and then you solve for y. So this is the algebra trick for finding a formula for an inverse function. Let's see if I can sneak it in. I wrote kind of big, but I think I can fit it over here. So this is to actually find f inverse. We'll say our equation for f was originally a y equals 4 times x plus 2 cubed minus 3. You can write f of x, but there's a couple of reasons I prefer not to. One is I don't really want to have to write f of x over and over and over again. Two is that when I get all done, I'm not going to call the output of this thing f of x anymore. I'm going to call it f inverse of x. So I think it takes away a little of the confusion in that switch if you just right away switch to a y. Okay, so first step, this is how I'm thinking of my function. I haven't done anything other than call f of x y. I switch x and y, and then I solve for y. So y is having a 2 added, it's getting cubed, it's getting multiplied by 4, and then we subtract 3, which means to solve for y, there's only the 1. We first add the 3 to both sides. Notice, is it still showing for you guys? Yeah, up here at the top, the first thing we said f inverse should do would be to add 3. The first thing we did when we solved was to add 3. The next thing I do to solve for y is to get rid of the 4. I do that by dividing. Divide both sides of the equation by 4. Again, if you look back up at our list, divide by 4 was the next thing on the list for f inverse. The next thing I would do to solve is to cube root, still matching up with my list up at the top. And the last thing I need to do is subtract 2. So I get the cube root of x plus 3 divided by 4 minus 2 equals y. And I'm going to go ahead, since I'm at the bottom here, and switch that y back to an f inverse. So I sort of did that problem in backwards order. We used the list to get the equations, and then we checked. My normal order would be first to do this algebra, find the equation for f inverse algebraically, and then I could do some checking to make sure that composition really did work. Let me think if I have anything else I want to say on this one. I don't think so. Thanks for watching.